Yo, guess who remembered to unmute his microphone today? That's right. That's right. That's me. I remember to unmute the microphone. Okay, while we wait for some people to get in here, I'll go get something. Let's see my other package. It did not. I got a package, you guys. Good morning, good morning, good morning. Get in here, get in here. I bought this yesterday. It is a MetaQuest 3. You'll never make it in Hollywood, baby. So we can, ADV shell. It's called a Eureka. It has 12 gigs of RAM. Yeah, right? Right? It's exciting. So we got this in the mail. This is my MetaQuest 3 Elite strap. It's slim. No, it's like identical almost to a Quest 2. If you're looking for something smaller than a Quest 2, you're gonna have a bad time. I would think. Elite strap, boys. Oh man, I turned off silence unknown callers on my phone. And just because I've been beefing with AT&T, don't let me get into my beef with AT&T. Yeah, I've been beefing with AT&T, and I turned off silence unknown callers. And someone called me this morning. Some woman trying to sell me some crap, and man, it was not her day. Do not ever call me. If you call me, I just think that like whatever abuse I choose to subject you to, you've opted into. Right, like I would never call someone and do that, but if you call me, see, why would I ever want this soft strap? We got a hard strap. Yeah, we hard strapped. Oh, I saw yesterday, my friend sent me that apparently people on Twitter like my LinkedIn profile. That's good for people on Twitter. I love when I cross over social networks like that. All right, let's how do I get this in? Want me to snap this? I'm sure there's an FAQ for idiots. Oh, perfect. All right. Is this the metaverse? Yes, it's the metaverse. Oh, man. No. I have to take this off, spin this around. Oh, there we go. Now click these back in. Now my beef with AT&T is going to be nothing like my beef with Qualcomm. It's already over. We're just going to move off them. They're dicks, man. But like you knew they were dicks, right? Did you ever think AT&T was staffed by nice people? Oh, yeah. Look, I'm in the metaverse now, guys. Okay? Now, you can't see me, but I can see you because I'm in the metaverse. Whoa, the metaverse. See, look, I can pick up this thing and drink it in the metaverse. This is the sickest metaverse ever. Look, I can interact with objects in the metaverse. They feel so real. I love the metaverse, you guys. Look at this. I own a Rolls-Royce in the metaverse. Look at this. This is a key to a Rolls-Royce in the metaverse. You guys can't see it because it's the metaverse. But, bro, I got a mouse, a metaverse mouse. And I got my microphone unmuted. Oh, that's kind of loud. This one's going to be loud. Wow, look at all this metaverse stuff I own. I got a book in the metaverse. Wow. Oh, that's not the metaverse? Oh, you got to go like that to go in the metaverse? Oh, you guys, I can't see shit now. Oh, I can't see shit now. I'm looking at my flabby body. I wanted to look like Chad in the metaverse. Why do they got all these avatars that don't make me look like, whoa, that was trippy. Whoa, that's trippy, man. I can like step out of my little metaverse circle and then I can return to my boundary. You guys can't see what I see because I'm in the metaverse and you're not. Wow, I thought I had a chair here. Oh, I do. It's right here. Okay. So if you'd like to join me in the metaverse, you can buy one of these things. Now, I will tell you, I will give you some cautions about buying one of these things. The tech is great. I can't believe this is $500. I love Facebook for making this. You know, you don't see Google making things like this. What does Google make? You know, it's lame, right? Like, you know who this is for, right? You know, like I understand that the metaverse ad might include like a diverse, you know, lower middle income family, but you know this is for like rich, you know, quasi-white basement dwelling tech dudes, right? Like, you know who it's really for. I'm sorry, that's who video games are for. I'm sorry, Gamergate, I'm sorry, that's just the way it is. Boys, I can't argue with reality. Look, all I'm saying, if, you know, all right, now we're not going on rants today, but you all know the truth, right? Like, everyone kind of knows the truth, and that's what sucks about it. I just wish we could all acknowledge the truth, and through truth we can find healing, you know? Through truth, we can find healing. But through lies and falsehoods, we're never going to find shit. And that is why the metaverse sucks, and why you might not want to buy one of these. But if they decide that the metaverse, that they're going to make a based metaverse, then the metaverse could be cool. But Mark Zuckerberg, I don't get, like, you know, man, you just gotta fire some people. You know what's up, man? Be like, yo, guys, we're making the metaverse based. But if we make the metaverse based, we might lose out on 2% of our customers in exchange for 98% of our customers. Exactly, bitch. Exactly. Exactly. All right. Topics that are immediately banned. Taking sides in wars. On this channel, we do not take sides in wars. We think war is a terrible tragedy, and we stand with the Chinese, okay? So whatever the Chinese think is what we think. Great. Because, you know, they're the new empire, and, you know, we're just trying to play our part in the new empire, right? So we stand with the Chinese. Whatever they think, we think. Right? Like, you know how people used to say, I stand with the Americans? Well, now we stand with the Chinese. You know, and I'm sorry, that's just how it is. Yeah. All right. If the Chinese aren't in the war, well, then I don't know, man. I don't know. If you can't beat them, then join them. That is exactly what I'm here to do, man. You know, so can I buy a Chinese Quest? No, come on. We still make good technology, right? Like, all right, actually, come on. You know where this was made? Maybe it was made in Malaysia. Let's see. Let's see if we can figure out. Where was Quest 3 made? Huge hardware bump, but who's it for? That's a great question. That's exactly what I'm asking. Why are all these games crappy mobile games? And why don't you make good games? I don't know, but you can buy your very own metaverse. You can ADB into it, which is kind of cool. Should we jailbreak it? No, we shouldn't, because that's stupid. That's right. All right. It's probably on the box. That's a good point. Let's check the box. And then, wow, I'm real hype this morning. I'm real hype. The metaverse gets me real hype. Okay, let's see. By using this product, you agree. Oh, it's UL Energy verified. That sounds vaguely global warming friendly. Meta platforms, one hacker way. It does not say on the box where it's made. It does not. Well, you know it's not America. Oh no, here, made in China, right here. Made in China. Found it. I don't know. It might be Malaysia or Vietnam, okay? It could even be Taiwan or Korea, you know? Hey, it's a pretty nice piece of hardware. But, Yeah, so it's made in China, so that is why we stand with China. That is right. We stand with China because China made this Quest 3. Okay? And when America starts making things, we'll stand with America. But until they do, we stand with China. That's right. This is a Chinese support channel. We support the Chinese, unless they're trying to do COVID lockdowns, because of course we don't support COVID lockdowns more than we support the Chinese. And that is just a fact. Okay, good. Now that we've said all the controversial things there are to say, let's take one more look at the Quest 3. Oh, it's beautiful. Oh, Quest 3, Quest 3. Oh, Quest 3, Quest 3. Wow, Quest 3. Yeah, how much of this went to tariffs? See? China makes great hardware. America then takes a cut of it for no reason. Not cool. Wow. Wait, serious question. Are electronics now cheaper in other parts of the world? Like during my whole childhood, America was the absolute cheapest place to buy electronics. But if there's now a 25% tariff on Chinese-made goods, are you telling me I can buy a cheaper Quest 3 somewhere else? And if so, why do I not live in that country? Like, is it cheaper to buy a Quest 3 in Malaysia now? It's the same price? All right. Well, when America is no longer the cheapest place in the world to buy consumer electronics, I'm literally moving out. I'm done. Had it with this bullshit. We're moving somewhere where they don't tax the Chinese arbitrarily because they're good. Okay, great. Oh yeah, no, nothing's cheap in Norway. We're not moving there. Sorry. Okay, Google, you can't know my location. Could be cheaper if produced by illegal immigrants in the US. I actually don't think that's true. And I think you'd have a hard time finding skilled labor. Like, guys, no. We're going to continue on this for a little more just because the Quest 3 is made in China. Like, you know what? Respect, right? Like, I have respect for that, right? So, I mean, we can break down the components of this thing. It's a Qualcomm chip. The Qualcomm chip is made in Taiwan. It's probably designed somewhat in America. So, you know, I have respect for the guys in San Diego who are designing chips. But mostly, America is just a tax on the world. Any company that sells you services are the absolute biggest scam. I never want services. They're priced. Just dealing with AT&T, it didn't like tell me, look, I don't hate AT&T the way I hate Qualcomm. Like there's actually something wrong with that company. AT&T is just, you know, it is what it is. You know, I'm not trying to do I don't think doing like a activist shareholder thing with AT&T would be useful, right? I actually don't think that AT&T's governance is the problem. I think they're just dicks, but like, okay, what are you going to do? Well, you go to another carrier, they're dicks, and it's all just a dickopoly, right? Qualcomm is actually, no, like, you're going to lose business if you keep acting the way you're acting. Like, Qualcomm could capture new sectors, and they are just going to lose out on these new sectors because of how they're acting as a company. So, you know, again, if you're a billionaire and you want to, you know, be even a bigger billionaire, we can do some leverage buyout at Qualcomm. I think it might be fun. But yeah, I mean, like, respect, right? Like let's talk about what we respect and let's talk about what we don't respect, right? Like people in AT&T figuring out how to scam you slightly better on cell phone service, no respect. People putting together Quest 3s, respect, right? Why do we not have these people in America? And instead we have the other type of person, right? Why is every job in America some fake bozo job, right? Like, what? That's not a job. Like, the world would literally be better without all of these salespeople, right? The world would literally be better without most jobs in America. right? The world would definitely not be better without whoever put the Quest 3s together, right? So respect and no respect, right? And you know, that's the only way we're gonna heal this shit, man. It's the only way we're gonna heal. We really gotta stop respecting bullshit. So yeah, no, we gotta. Yeah, MediaTek is, you know, they're sending me overpriced shit. They think they can scam me because I'm an American and don't know real Chinese prices. Guela. That's right. Reselling Chinese goods on Amazon is a respectable job. I mean, yeah, that's more respectable than a lot of things, to be honest. Like, the level of, like, I'm talking literally about all the jobs in America. And it's got to be like 20-30% now, where if these people were shot dead tomorrow, everyone else's lives would get better, right? Like we now have so many people who are against the system, who are against moving things forward, who are actually making the world worse, right? Not just doing nothing, actually making the world worse, right? Like, remember that survey I did? Are you part of the problem? You know who's definitely not part of the problem? Like, who's ever screwing this together, right? Who's ever running the pick and place machine that makes the boards in here? Who's ever placing these cameras and putting the little things in, right? Like, that person's not the problem, right? The kind of person who works in, like, again, a job where it's basically your job to tell other people no, right? Who is the bad art friend? What is this article? Oh my God, I can't believe we're going down stupid rabbit holes. Look, we were going to do work this morning. I was doing so much work. And then what was I triggered by? I was triggered by something. I don't remember. Wow, we're really hyped up. Oh my God. Like, you know what the worst part is? I kind of even remember this. It was 10,000 words, and I read like 2 paragraphs of it and was done. Yeah. Yeah. I think it's the person doing the job, not the entity, right? I think we have to target the people, not the entity. The problem with targeting the entity is corporations are psychopaths, right? We just have to accept that. We just have to accept that corporations are going to behave psychopathically, right? You can try to rein them in with regulations, but there's a much better way to rein them in, and it's just like people need to say no. Like, we need a culture where people care about their jobs. We need a culture where people don't want to be a drain on society, right? And if you want to be a drain on society, you know, bullets are very cheap, right? And I mean this. Like, this is going to be the only way to deal with this shit. Like, I can't believe it. We have so many people out there who are literally making everybody else's lives worse, right? And I want you to really think about that. I want you to really think about, does your job just make everybody else's life worse? Okay? There's a whole lot of people who do this, right? Think about all the people who block housing, right? Think about all the people whose job it is just to stifle other people, right? Your job makes life worse. See, we got one acknowledged here, right? So stop doing it, man. Like, stop. You are a bad person, right? It's that simple. No, I'm not trying to say these people have names and addresses, right? Like, we're never really going to fix it from the outside. We have to fix it culturally. We have to have your friends shame you. We have to have everybody shame you. We have to have everybody say that what you are doing is not okay, right? I'm more okay with murderers and drug dealers than I am with you, right? Not you know, indiscriminate murderers, but I'm actually more okay with murderers and drug dealers than you, because murderers and drug dealers, everyone in society understands what they are and who they, you know, and what they do, right? It's these people who, they are just taking a tiny bit from every single person. And there's so many of them now. And, you know, the only way to deal with this is shame. Guy with a comfortable AF life. Give up your job, peasants. Well, yeah, but my life wasn't always comfortable, right? My life was comfortable because I structured it to be comfortable. My life at, like, when do you think my life was comfortable? When I lived in a van? Right? Like, you know, when do you think my life was comfortable? When I didn't have money? Like, no. I worked, I earned money. And now my life's comfortable because I'm not, you know, 18, 19 anymore, right? If you're 30-something and don't have a comfortable life, like, ask yourself why, right? Yeah, exactly. I mean, no one's 20. No one's. If you're comfortable in your early 20s, yeah, you were born with a silver spoon in your mouth, right? Like you shouldn't be. Right? Your early 20s should be uncomfortable. Man, I used to be too cheap. You know, I brought my girlfriend to Canada on a road trip. I was too cheap to get a hotel room, so we had to sleep in the basement of a college. I'm like, look, you could just go to any college and sleep in the basement. No one's gonna bother you, man. And you're like sleeping on like a little couch at 4 in the morning, right? Like, you know, so don't sad in the struggle, bitches, you know? How comfortable was early 2010s China? I mean, comfortable, I don't know. Like, I wasn't rich. But the cool thing is, you didn't have to be rich, right? Okay, let's code. Yeah, how comfortable was getting fucking sued by Sony, you know? You want to talk about struggle. That's right, but this isn't going to be a struggle Olympics, guys. Like, you know, there's definitely people who have it worse than me. There's people who have it better than me. I'm somewhere in the middle, right? You can't control that. All you can control is the choices you, as an individual, make. Right? All you can do is control. You don't choose where you start, but you do choose where you end up, right? And anyone who doesn't believe that, the only cure is a bullet. Is there free will? Why does it matter? What? I don't even get it, man. You wearing a blanket? What? You like my sweater, boys? My sweater? Free Willy. All right. Free will is the stupidest circle jerk conversation ever. So we're going to subscriber only chat. Okay. So you guys remember the example from last time? Hand code resnet 50 opt. So it actually got slower. Yeah, use tensor cores. Okay. So first off, this one was kind of stupid. We'll get rid of that. We'll get rid of that. If tc. Wait, use tensor cores. Okay. Plot. Mario Bean, thank you for gifting subs. I remember you gifting subs last time. You are great. Okay, hopefully we're now back to kind of where we were. Why is this so slow? It shouldn't be slow. Mario Bean living that ultra comfortable life. I don't know about that. Oh, okay. So yeah, the problem is tensor cores don't always get applied, right? So sometimes we get 2 here and sometimes we get 1. Problem is we weren't doing any optimization. Okay, so you see those ones can't even use tensor cores. Why is this so slow? What's going on here? Oh. See the problem? Well, no. I mean, if you're comfortable in your early 20s, it's because you were born rich, right? Or you had someone like watching out for you, right? But you know, your 30s are up to you, right? College basement sofas. I slept in the Princeton Library once. It was pretty nice. I slept in the sofa at McGill. It was less nice. I slept in a room in Cornell. That was chill. Can I give a quick overview of what we're going to do? Okay, so this is just what we wrote last time. I'm just fixing it to match the new API.
So here, let's just always try hand-coded opt. Maybe try tensor cores. Requires one positional argument. Use tensor cores. Wait, what? Oh yeah. Whatever. Just gonna make that equal 1. Whatever. Okay, great. So now this is optimizing the resnet 50. And it's going through all the kernels in the resnet 50 and figuring out the speed of them. Okay, so we're getting 392 milliseconds, and you'll see like this one here, we try both with no tensor cores and with tensor cores here. And so for ones where we can optionally use the tensor cores, we try tensor cores. Okay, cool. Now let's add a new kind of search, right? So this is the speed at which we're running, and I can get rid of debug equals 1 so you can just really see the whole thing. This is the speed at which we're running a resnet 50 with batch size 64. All right, so we take the resnet 50, and then we figure out what kernels are actually used to run it, and then we optimize the kernels. All right, cool. So we have some new fun infrastructure that will let us use less of this. So I wrote some new code, and we can read it. It's in code gen search. So it's a bunch of functions. Time linearizer. So time linearizer returns a tuple of 2 floats. One is the returns time in microseconds and gigaflops. From typing import tuple, takes in a linearizer. Why don't I have a linearizer? Oh, I don't import the linearizer. Interesting, I don't actually need the linearizer, but we should do it anyway. Code gen linearizer, import linearizer. Okay. This also takes in a linearizer and returns the buffers. And this takes in a linearizer and returns a dictionary from an int to a linearizer, where you can see all the possible actions, okay? Enumerate. Actually, let's go over quickly what an action is, since all this stuff is new, okay? So here's a whole bunch of actions. See, we got some upcasts, some locals. This line is really, really, really long, unfortunately. There's 160 possible actions that you can take. And then these actions are upcast, axis 1, amount 21. Upcast, axis 3, amount 27. And I got all these actions by generating a test data set of kernels. So I generated a test data set of a huge number of kernels. Actually, we can see them, they're in sobs. So this is a huge number of test kernels from all the things in tinygrad. So what's a kernel? If you don't know what a kernel is, you got to watch a lot of videos because we're not going that deep. But I will show you all the stuff that's new. So I have a file in extra optimization called generate dataset, and this will generate all the operations basically from all the tests inside tinygrad. So these are all the possible actions that are taken by all the possible kernels in all the hand-coded optimizations. Get dictionary of all possible actions. Okay, and then this is a raw buffer. tinygrad.runtime.lib import raw buffer. So this is going to be a list raw buffer. And this is going to be a list of raw buffer, and so on and so forth. Okay. Okay, cool. So it's basically these three functions that I wrote: time linearizer, buff from lins, get linearizer actions. Now, you'll see that we can start to use some of these instead of the other ones. We don't need that anymore. tinygrad.codegen.search import. All right, here, for example, we can do lin buffs from lin. Now, right here, we can say buffs from lin. So are we doing good using the new infrastructure? It's all about building infrastructure, guys. Everything in life is infrastructure. You make your infrastructure good, you're Singapore. You make your infrastructure suck, you're Somalia, right? It's all about building infrastructure. Why are those buffers slower? That doesn't make any sense. Or that might just be measurement error. I don't know. Let's run it again to find out. Wait, they're slightly slower. I can't believe that. They can't actually be slower, can they? They're slightly slower. I don't really understand how that can be, but whatever. Buffer items, max size of all the ones that come in, that's fine. Can I make the font a bit bigger? Yes, only because you gifted subs. Normally I'd tell everyone to fuck off with that request, but since you gifted subs, of course. So there you go, it's a little bigger. I can't make it too much bigger because then it's really hard for me to say. Okay, and then this, should we just not return the time in? It's a little annoying that we don't use seconds. We should probably just use seconds. Thank you for gifting more subs. Yeah, let's just not use seconds, right? Return time in seconds, right? Okay, cool. So here we have time linearizer. Oh, and here we can just use, instead of lininfo flops, we should just use gflops. We can import time linearizer from here. Lin, we don't need this. This should actually also be faster because it doesn't always do the whole thing. So let's just copy and paste this here and write gflops equals that. Choices. Everybody has choices. We're missing raw buffs. We gotta pass the raw buffs in. Linearizer object has no attribute display name. Yeah, because we don't actually we copy the linearizer here. I'm not sure we're gonna do that anymore. Actually going to leave that and get rid of display name here. Change this. I added some new. I kind of like display name actually. It's kind of cool. Never mind. So yeah, I mean, if you're not following this, go watch last week's stream. Good. It's a little slower too for some reason, but whatever. Why is this faster? That's a real question. Get to the bottom of that at some point. Okay. Good. We don't need this crap anymore. See if debug equals 1 still works. Great. Okay. Now, so does everyone see what we did? We just kind of took what already existed, but we rewrote it in terms of the new infrastructure. Now, we have some even crazier new infrastructure. We can try a greedy search. We won't use buffs from one. Let's just do that for now. A little bit slower. It's like a couple milliseconds slow. Wait a second. No, that's slower too. Okay, so time linearizer is not as aggressive. Time linearizer does all these things. We should actually print factor here. Let's see. Factor is this thing. In order to benchmark, so you see these things here? If they're really big, you don't actually have to benchmark the entire thing. You can just benchmark like a subset of it, and you get pretty much the same thing. These are the global dimensions in CL. So you'll see some of these are using like a reduction factor just in order to get more speed when we are evaluating the speed of things. So great. Try a brute force search. Okay, so while one, I have a, so I shouldn't say a brute force search, I should say try a greedy search. I have another file here called greedy. We are first going to time the linearizer. Then we have another function here called getLinearizer actions. This shows you all the possible actions that you can take from the linearizer. So again, what are these actions? We can do things like upcast. We can do things like local. We can do, well, the whole list of actions is here in Optimizer. Upcast, local, group, group top. You choose an axis and you choose an amount. And this is like an optimization action. Okay, so we want to time all of these. Okay, timeLin.keys. In fact, here we only need the time. I don't really care about the gigaflops. So we can just get the time here. Values. Values is less than time. If min time value is greater than time, break. Then here we want to do another one. We want to say lin equals acted lin sub time lin. We want the arg min of that. How do I get that? Can you increase the font size? Did you gift any subs? No, you didn't gift any subs. Why would I increase the font size for you? You are a sub, but I don't know. You subbed, that's not how it works. Normally, everyone asks to increase the font size, and really, this is a problem with your monitor. But since Mario being gifted so many subs, we're of course going to increase the font size for him. Man, I regret subbing you. You know what? Font got smaller. No, we'll leave the font the same. Oh, I regret subbing you. Wow, what a guy, man. What a guy. If you sub 100 people, no, because you're only doing it because you're a dick. And you know, we can't have that, right? Like, I'm not a greedy guy. We live in a nice society here, right? Like, this is welcome to my nice society. Okay, wait. How do I get argmin? Imagine regretting $5. You're just joking? All right, that's good. That's good. Okay. Wait, how do I get argmin? You see what I want to do? I want to get the one that's actually the minimum here. I guess I could do this. Okay, well. Why isn't deep copy working? How come deep copy was working before and it's not working now? Oh, maybe because I gotta do it in that order? Yeah, that's good. Here, okay, so this is the linearizers and all the times they take, right? So you can see this one here takes, what? That time doesn't make sense. Oh, maybe it does. Maybe that's actually how bad it is. Because that's like a lot of milliseconds, man. Okay, well, if we take action 82, it's the best action. Okay, if opts sub0 sub1, right, this is 0 sub1 is less than time, we're done. Otherwise, we'll take acted lens opt 0 0. Right? Now let's print len.colorShape. Oh, man, why could I not copy here? I broke something. Okay, that's at least working. Okay, so you see, it's now searching and it found that and it found that. Here, what I was doing here was also printing the no attribute display name. Yeah, that's because we have to not copy here. So see? All right, there we go. Look, that one's faster. Oh man, that's so much faster now. right? Look at that. See, this one here was taking 11.94 milliseconds. But now, with the power of search, we found one that takes 7.47 milliseconds. So, when we're done with this, we're going to lins.append lin. And we're going to comment that out because that's stupid. Oh, well, you know, we'll gate it behind a debug. Debug equals 1. Now we're going to see all three options, right? So we have the hand-coded option, the TensorCore option, and the greedy search option. And now, unfortunately, greedy search is very slow. But look, 7 milliseconds instead of 11. And only sometime we get that error. Okay. If length opt equals 0 or, yeah, okay, good. Fine, we'll do debug equals 2. And we'll put this in debug equals 3. Oh, that's not showing me all the launches. Never mind, I don't want that. All right, so that's like the best one there. All right, now it finds another one that's 7. Okay, cool. Right? But now, instead of taking 11.8, we're taking 7.01. Now it's optimizing the next one. Yeah, look, this is faster. I mean, it didn't get that same time there, but it's faster. Okay, so this one, the greedy search didn't win. The greedy search was slower than the TensorCores, which were the fastest. I'm also going to print which number kernel it is. So like you'll see that I can comment out the greedy search here and it's like still fine. I'm gonna put the number here. Yeah, I did that. I don't know why I didn't. Oh, it says kernel 31. Oh, I don't know. Okay, cool. So last time we were at kernel 2, we were at 13 milliseconds, but now we're at 8 milliseconds. That's so fast, boys. That's so fast. Now we have infrastructure to do a greedy search. And the great thing is we can replace this infrastructure with any kind of intelligent search I want. So when I mean the search is greedy, right? Does everyone understand like what this kind of looks like? Does anyone remotely understand what this kind of looks like? Okay. Why are you subscribers off topic? We're programming now. Why are you off topic? It checks every permutation, but it's actually not every permutation. It's greedy, right? So there's an action space of, actually, you know what? I'm going to add one more thing here. Okay, so like it checked 36 actions and it found the best action was to make that 16 local. It checked 39 actions and then it upcasted that 16. Checked 31 actions, upcasted that 2. Checked 39 actions, upcasted that 4. So it's greedy in the sense of it takes the best action at locally each time step, and each thing's there's about 5 optimizations applied. This one had a bunch more. And didn't even end up winning because the TensorCores won. All right, so remember that the resnet was at about 400 milliseconds when we started this. Let's see now what we can get it down to. See, that one greedy didn't win either. That one, both hand-coded optimization and TensorCores were better. This one, TensorCores won. And so you see this middle one here is tensor cores because it has that weird thing. That's hand-coded opt and that's greedy. I'm actually going to also thread group memory size exceeds the maximum allowed thread group memory size. Interesting. Okay, well, we only made it to kernel 7. I'm going to add count there. So for this one, I'm just going to do a bunch of allow test size equals false, count equals 10, should copy equals false, right? And that kind of matches the old behavior. Okay. So this is just the old behavior of the function. We give it 10 tries, we don't allow the test size. Okay, so we're at 394. Before we errored out there, we were at this. Okay. Let's just wrap this in a try except. Well, actually, because this would have to fail. Okay, that'll re-raise the exception. That's interesting. It's a runtime failure. What I really want to catch is compile failures. So you see how all this infrastructure can be used for fuzzers too? Like that's where I really want to go with this. I want to get this to the point that we are that we're fuzzing. All right, should I throw a quick cache on this just so we don't have to sit here? Google has a Kaggle competition about training a network to predict runtimes. Yeah, it's really very similar to that. Just ignore the one that crashes. Yeah, that's a good point. Yeah, instead of re-raising, you're right. What I can do, instead of raise e here, I can just return float inf 0. That way it won't get picked. In fact, it'll never get picked there. Okay. We need to cache this quickly. What do I use in KOP? I have some like stupid cache thing. Shells. We can call this the greedy cache. Okay. If sterling ast in global DB, does this like work? Len.apply opt AO global DB subster len.ast equals len.apply ops. Does that work? need to pickle it? Is it a string thing or will it auto pickle for me? Okay. Now let's try running that again and see if we don't do the first one. Oh great, oh, we didn't do it. Okay, cool. But for some reason it didn't add the linearizer, but that was probably my fault. No, it should apply the ops there. Oh no, there's no tensor cores there. Okay, great. Okay, cool. So I just put a cache on the greedy. It doesn't. This one tests 10 times. All these other ones are doing it 3 times. Like if you look at the default in search, it's count equals 3. It's fast now. Okay, we're at kernel 11 with 27 milliseconds, and we used to be at kernel 11 with 32 milliseconds. We've saved 5 milliseconds. How much is the variability of each run? I don't instrument that right now. But like these would be good things to instrument, and it'd be really nice to just start like also, we're also not checking the correctness of these things. There's a chance that some of these ops are incorrect. So, you know, fast first and then correctness later, but we should be checking the correctness. See, look, we saved 3 milliseconds there. Oh, that's pretty nice. 3 milliseconds there. Oh, this is going to be fast. Okay, so we also don't need to be this greedy. We can also try other search strategies now, like nevergrad. But our infrastructure's gotten good enough that we can like write a greedy search and not that many lines with basically get linearizer actions and time linearizer. So in the same number of lines, we've written an example that how much is variability? Well, it's clearly something because this one runs it again and it's not good. It's like tensor cores win there. Hand-coded op wins there. Oh, and cool. If it hits the same kernel again, I guess it just uses the same, it's going to be the same AST. So that's nice. Okay, we're sitting here watching optimizers run. That's never good. I mean, this isn't that slow, though. We're actually searching a very large search space. See, this one lost to the hand-coded. We should be writing a fuzzer. To check the correctness of these things, but I think I'll leave that as an exercise to the reader. I'll try to upstream this after the stream's done, and then you guys can play with it. So this greedy search is just one way to search the space. Messing with searches is a whole lot of fun. So I think that like you guys are gonna have a good time. messing with like all the different kind of ways to search this space. So this greedy, by the way, is not, it does not search all the possible points in the space, right? You can imagine each node, like at the first node, there were 33 things out, right? And then we expanded one node here, and then there were 31 out. And then here we expanded at node 20, right? But there's lots of other ways to search spaces. So we can try these searches, and we can figure out which searches are the best. So I think turn greedy off, try your resnet, and see how much better you can get with greedy. See, like, look at what a win greedy was there. 32,000 gigaflops instead of, it's like 3 times faster for that kernel. Why not extract the search to a function? Yeah, I could, but it's not a very good search, right? So I don't think it's time for it to be a function yet. I wrote like helper functions that are pretty useful. We should probably figure out why buffs from Lin is slower. If you did search every permutation, it would always win or draw with hand-coded. Absolutely, yeah. Because all of these action spaces are available in hand-coded. So you'll see where I generated this stuff in one of these things here. I actually confirmed that to be true. I don't know where it is. But where I actually generated the action space. Sorry, this is like junk cleanup code where I was like trying RL stuff. And then I'm like, it's not time for RL. Let's just try greedy optimization and see if it's good. Oh, this is lagging the computer. Wow, look at that. There's another one. What a win. Okay, it took some bad step there. But it found that. I don't know how much faster that's going to be. So I can go into a little bit about what the, wow. Look at that, 10 times faster. That's so good. Sorry, not like 7 times faster. So what these things are is these yellows are output space. These purples are unrolled loops. The reds are reduced loops. The cyan is locals. And then the blue are globals, right? Look at that speed up. Look at that. I have no idea. This is going to be so fast. I could add a summary to see which method performed the best. Yeah, I mean, you can kind of just look at it and know it right now, but I could label these linearizers where I add them, right? Like I try 3 kinds of things. But this is a good place for people to play with search algorithms, and this is the main thing I wanted to show off, which is just like how easy it is now to write searches in tinygrads for fast stuff. We're going to see how much better we do, and then I think that's today's stream. Nice short stream. I'm sick of doing the long streams, you know, they kind of just like, I'll go in, we start with a little rant, and then, you know, we rant about the phonies, and then we do a little bit of coding, and then we're good. How many kernels were there? I forgot. Oh, we're almost done. Okay, so 58. So we're at 48 and we're at 167. Oh man. Oh man, this is fast. This is way better than kopt equals 2 ever was. We used to have an old optimizer in here called kopt equals 2, and kopt equals 2 was like just, it was terrible. It was not well thought through. It was bad code. The action space wasn't well thought through, but now we've thought through the action space. We've written helper functions. Oh my God. Look at that speed. We'll raid Lanalox, absolutely. Look at that speed. Let's turn the debug off. We just doubled the speed. M1 runners on GitHub. Do I have to pay for them, or are they just good? Oh, it just looks like a public beta. Oh, oh, beta and pay? Oh, how much are they? Oh, that's expensive. It's gonna cost like $1 every time we run the thing. No, per minute? Wait, that's insane. It's $7 an hour. I can get like A100s for that. Oh, it's so expensive. Okay. Take a look at what we just did there. With greedy equals 0, without the new greedy search, with just the hand-coded optimizations and tensor cores as an option, which is not even as good as what's normally in tinygrad, we're getting run times of 393 milliseconds. When we turn greedy on, now we're using cached greedy, it's way better than kopt ever was, and greedy still is not even searching the entire space. I think we can beat this with reinforcement learning. I think that's undoubtedly faster than Torch on this platform. Torch on this platform is not that good. Yeah, we can apply it. We can apply it to HLB CFAR. Yeah, I mean, that's mostly what I wanted to show you guys. Just how easy it was to write a real search, and we just have the running speed of that thing. And yeah. Well, okay, like we can look at our gigaflops there, right? Like we can look like all the stupid slow ones got fast. Oh, remember that one that we tried to hand optimize last time? That's like the only one that didn't get fast. Like look at kernel 50. No, not 53. Well, even 53, like look like we doubled the speed of it. So we're searching. You see these. And I don't know if the ones that use green are actually correct. I hope they're correct. Someone also needs to write a fuzzer for this. Okay, so we need a fuzzer and we need improved search methodologies. And the key to search also is being fast. Like this search is way too slow. I'm just gonna push what I have here. I will leave you guys with the bitter lesson. Where can you find the previous streams? You go to George Hotz Archive, or you can subscribe. Actually, you're a subscriber, so you can just watch them right here on Twitch. Yeah, we really picked the wrong one last time. Yeah, we got unlucky. I mean, even the auto opt couldn't find better ones really for that. But yeah, we just doubled the speed. And this stuff is super universal too. So this is going to make not just Mac fast, but it's going to make every platform fast. And then, like I said, we can do better than greedy, right? So unfortunately, searching the entire search space now is like a massive, massive thing. If we wanted to search every kernel in the search space, it'd be combinatorial this kind of. So let's just get a quick idea. Yeah, we have to search something that size. And that's assuming that at each node, like it's the same number of actions, right? So it's possible when you expand, like from this 23, we only expanded this node. Can you guys all see this as a graph? Like here you are at the top node, there's 23 lines coming out. Then you go to this node, there's 25 lines coming out. Then you go to this node, there's 25 lines coming out. So all the possible permutations is something like 5.4 million. So this is a greedy optimizer. We can also try improved nevergrad in the new space. I have an idea nevergrad in the new space is going to be a lot better than the old kopt was. Also, this time linearizer function is a lot faster than the old one because of allow test size. And you can look at time linearizer and you can see how I wrote that. Basically, if the global size is large, we divide the global size and then just multiply the runtime by what we divided the global size by later. Yeah. If the pruning algorithms they use for chest search, I mean, it's really, it's the same. And then like at each node, you know, this is like simpler than most RL because at each node you already have like the exact value. You know the exact value of the state, and the value of the state is exactly, you know, its runtime. Take random samples from the search space and use gradient descent to find the bottom. How can you use gradient descent? I don't know if it's, what do you taking the derivative of. You can certainly use evolutionary algorithms, right? There's no real derivative, and that's why you have to use RL and stuff. Is what kind of? I mean, yeah. So you can try, like, I think you could write never grad in here. Do you think anyone can get it under 100 milliseconds? Well, you know what? Let's see what the theoretical. Can I just average all the gigaflops? No, I can't average all the gigaflops. Okay. We can do running gflops equals this. And then what I want to do is this equals gflops times time. Divide that by total time. So now we're going to see the total gigaflops. So you can see the ones that use tensor cores get almost 8. This matches like the best you can get with what do I do? Yeah, sure. Sample 2 points next to each other. Sounds good. Yeah, you can write all kinds of searches here. Okay. Wow. That's still a pathetic amount of gigaflops. We can go way faster. So that's 2.7 teraflops. The theoretical max of the GPU is something like, I think the theoretical max of this GPU is 10.4. So let's look it up. Yeah, 10.4. Stop asking for my location when I'm multiplying things, Google. You're being creepy. Okay, so we're at 26.5% model flop utilization. Like, we can do better. But wow, the other one must have been really bad. Like, without greedy, it's a terrible number of flops. Can I use simple branch and bound algorithms? Well, I don't think anything's really guaranteed to find the global optimum. Wow, we actually made it twice as fast. Cool. Also, we didn't check the correctness. So again, if someone wants to check correctness of this stuff, that's cool too. Yeah. Hey guys. Do we have anything to talk about in the last couple minutes of the stream? I just wanted to show you that we made it fast, that's all. And how you can help make it fast. You can test this on your hardware. tinygrad. If we write a really good RL version of this, right, like I said, this is not the best you can do. This is greedy. If we replace this with RL, the beauty of RL is once we train the model, there won't be any time at runtime. At runtime, it'll just it'll just pick the best action from the RL and plow through all of it. So we're going to be able to get the speed of, we're going to be able to get like inference speed part of the problem with some of these things, like you can use tensorrt, you can use tvm, they have searches, but the searches are very, very slow. And we can get into like why that is and why they don't just do this. But it's a lot easier in tinygrad to do this because our action space is a lot smaller and our action space is a lot more understandable. But they have action spaces that are a lot more complex. You know, it's not clearly expressed as like one shape tracker. So I have some start stuff with RL. I have some like getting features from the linearizer, putting features into a model. You can check that stuff on my branch, but I'm also going to merge this branch in with this, and then we can start using those search primitives. And also, if somebody wants to do the cleanup work to rip out the old one, that would be great too. We can rip out the old kopt stuff, replace kopt with greedy kopt. Greedy kopt's a lot better. And then also, you can try to use nevergrad here, and I think nevergrad might even beat greedy. But now we have real benchmarks. Like we're not just like kopt is like a throw things at the wall and sometimes you got lucky. This is a methodological way of approaching search. And if you approach search with a methodology, you get success. If you approach machine learning with a methodology, if you slowly build up infrastructure, and then only when you've pushed it to the limit with your hand-coded search, then you start to use really fancy search methods like RL, you can blow past the hand-coded search. But if you can't beat if you don't have a good hand-coded baseline, yeah, you're not gonna beat your search with right. Like think about, remember Twitch chess when I tried to write a chess engine and I ended up just writing the stupidest greedy search and it beat me? Yeah. Okay, hablo inglés en mi casa. No español en mi casa. No hablo con cama. Portugal es malo. No me gusta Portugal. Oh, you're a subscriber. Wow, I didn't notice the star next to your name. You know what? There's tiers of subscribers. And there's some people who talk about being a subscriber. Look, there's some people who just drive a Rolls-Royce, and then there's some people who bring it up every stream, right? Like, you know what I'm saying? Performance and safety, choose 2. Zig has 4. Are you shilling your language? Or never use Zig? Want to change the star to a comma? No, then I have to learn how to use these platforms. No, I'm kidding. I just bought a Rolls-Royce key so I can talk about having a Rolls-Royce. You think I actually bought the car, guys? Why would I do that? No, and then I use Stable Diffusion to generate pictures of me in a Rolls-Royce, and then I post them to Instagram. So I suggest some stuff to read if I want to get familiar with this library. Yeah, the library. It's short. You can read all the code in tinygrad. It's 4,471 lines. This is all the code in tinygrad. And most of it you're not going to have to read. Pick a car to flex. What, my Chrysler 300 isn't flexing on you? Nah, bro. Bro, I got a 2008 Dodge Charger, bro. Sebsy, you're going to get banned. You're going to get banned. You know I banned subscribers on this channel, right? I'm rich and want to spend money on your product. Why do you put a space in between the last word and the exclamation point? Whenever I get an email like that, I'm like, ugh, third world. 2008 Dodge Chargers flexing cal. When am I running for president? I'm not, guys. I'm just here to enjoy the decline. I learned that from Aaron Clary. Indian scammer vibe. Yeah, that's right. Lol, space, exclamation point. You know, it's the little things that give them away. It's against the law to ban subs. Yo. Alright, but no, what should you read to get familiar with tinygrad? You should literally just read tinygrad. It's very short. You should try some stuff, mess around with it. Yeah. No, not this again. Not what? Law in this stream. All right, you guys, go be nice to, let's see what Lon Alex is streaming. Wait, we should do it from this browser.
Welcome to Freddy's. We must be new security guards. But I want this place as
Wait, you're advertising being the producers of Megan?
I couldn't find a sitter.
Have you met them yet?
Met who?
I watched Megan. I wouldn't advertise being the producers of that.
Never last.
I don't know why my ad block isn't working for this. Did I see the Lex metaverse? Yeah, how come my metaverse didn't look like that and my
Hey, I'll be right back before we test it. So far, so good. Oh no, you know what? I gotta do 6 more things. I gotta do the camera position.
when does Strain come out, I wonder?
Lights, I changed the
All right.
thing.
Enjoy.
Application spot was fine, just the camera wasn't. And the camera camera switch to third person view. Yeah, there's a fade. Be right back and I'm gonna take it.
Oh no! No, I thought we were gonna test things. No.
Look who it is. I just saw a tweet about you. Oh my god, it made me laugh. Hey George, what's going on? You guys know Hotz. Fellow dev streamer. I just saw a tweet about you today. It was your LinkedIn profile. You probably saw it. It had like thousands of likes. Have a good stream. Welcome in, guys. Yeah, I'll go take a snack break later. What was I doing? Oh, you guys are welcome. You guys are joining. Welcome. My name's Lana. I'm a game developer. I'm making this game Strain. It's a first-person survival game where you are stuck in an apocalyptic city, post-apocalyptic city, and you need to survive. It's walled in. You gotta turn on electricity, build generators and other stuff, shelter, trap stuff, scavenge stuff, fight off other wild scavengers, navigate the storyline, punch stuff, smash stuff. You're the next president of Portugal. Okay. I didn't know that was on the agenda. Are you working in Salone? Yeah, for the most part. Hiring people to help with things where I can. Mostly asset creation, because that takes the longest time, honestly. Voice acting, of course. Hey, Mario, thank you for the bid. We're just talking about it on stream. What's that? Which thing? Can you go on a date with him? He's really shy. I've noted, yeah, he seems really, really shy. But ignore my viral contributions. I would rather go to Portugal for that. Wait, I'm missing so much. My friend sent it to me. Oh, okay. LinkedIn swag. How was that stream? I thought it was testing things time. Oh, I stepped away just as you rated. That's okay. I heard the sound. I was like, I think I'll see what that is. It's always a bad timing with rates. One thing I noticed is a lot of people are like, oh no, you just rated me, bad timing. And I realize I'm like, oh, I'm rating you because I don't usually see you on. So like a lot of the time, I raid people who I'm like, oh, so-and-so's on. I finally get a chance to raid them. But they're only on because they worked way longer than they usually would. So they're probably going to wrap up soon. It's not like I didn't plan that, but I see them on. I'm like, oh, I'm going to raid them. And they're like, I was just wrapping up. And there's a lesson there. And it's never stop streaming. Never stop streaming is a lesson. Being president of Portugal, how much he loves Portugal. I've never been, but I heard it's pretty cool. Is it a good place to be president of? So let me show you again a bit. Oh, you can't build here because we're not in the build areas. But you can fight. You love Singapore. Oh wait, no you can't. Oh my goodness, what happened? I don't know what I did there. I just